With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So let's see this question. In this question it is given, how many of the following compounds have significant involvement of d orbitals in p bonding, right? So let's draw each and every structures one by one. So the first structure is of H3PO2. So if you draw its structure H2PO2, right? It's H2PO2, the first structure. So let's draw its structure. When H2PO2, how we will draw? Phosphorus is the central atom. O is linked with a double bond, and then you have hydrogen here, and then one more hydrogen like this, and then finally you have O minus here, right? So this is the structure of H2PO2. Now you can easily see that here this P double bond O, here there is d pi p pi bonding. So when you have d pi p pi bonding, definitely it will be counted. It will be counted because you have to say these compounds involvement of d orbital in p bonding, right? So this is d pi p pi, so definitely it will be counted. Now let's see the second one. So when you want to see the second one in BCl3, so if you want to see the second, now we have studied that in BCl3 there is p pi back bonding occurs, right? P pi back bonding occurs in BCl3 because it has because of the empty p orbital and the lone pair of electrons. This back bonding occurs, which is p pi back bonding in BCl3. So definitely BCl3 is not going to have the d orbital in p bonding, right? Now let's see the third one. If you see the third one, then third one is H2S4O6, right? So let's draw its structure first. So definitely its structure looks like this. You have OH, and then you have this S double bond O. Here again double bond O, and then this S is linked like this. Then finally you have one more S double bond O. Here double bond O, and finally OH. This is the structure of H2S4O6. Now again you can see very well that there is involvement of d pi p pi bonding, right? The vacant d orbitals, so there is involvement of d pi p pi bonding here between S double bond O, S double bond O. So you will say that it will also be counted, right? So this is the second one. Now let's draw the fourth compound. In fourth compound it is given XeO6, right? It is XeO6. So how to draw this structure of XeO6? Let's see. Its structure looks like this. Let's draw the structure of XeO6. It is Xe, then double bond O, then again double bond O here, then O minus here, then OH here, then O minus here, and finally you have here one more O minus. So this is the structure of XeO6. Now here in this structure of XeO6, what is important? You can see very well that there is again the bonding, and these bondings are d pi p pi bonds, right? D pi p pi bonds, the double bond O. So what you will say that it is also counted in the structure. So you will say this is third one, that is in d pi p pi bond formation, right? Now let's see the next one, the fifth one. The fifth structure is XeOF4, right? XeOF4. So if you draw the XeOF4 structure, how does it look like? XeOF4, it looks like this. Xe, then double bond O, then you have F here, then one more F here, and one more F here, right? And here's the lone pair. So this is the structure of XeOF4. Now again you can see very well that there is presence of d pi p pi bond, right? There is presence of d pi p pi bond, so it will also be counted. So 3, then this is 4. Now FeCO5. Now in metal carbonyls we have already studied in coordination chemistry that metal carbonyls FeCO5 metal carbonyls have involvement of d orbitals in pi bonding, right? D orbitals in pi bonding. So we have already studied this, that metal carbonyl, they have involvement of d orbitals in pi bonding. So yes, this is also going to be added. So this is fifth one. Now let's see the sixth structure, SF6. If you draw the structure of SF6, how does it look like? Let's see. SF6 looks like this. You have sulfur and then finally 6 chlorine atom attached to it. So you can see there is no pi bonding, right? There is no pi bond, and so there will not be any kind of no pi bond, so there will not be any kind of d pi p pi bonding in SF6. Now let's see the next structure after SF6. So definitely you have BCl3 has been cancelled out and SF6 has been cancelled out. Now let's see NH4Cl. NH4Cl also does not evolve. We know very well that NH4Cl, there is no pi bonds in NH4Cl. We know very well. So this will also not counted d orbital in p bonding. So NH4Cl will also not be counted. Now let's see about ClO2. So what happens in case of ClO2? In ClO2, the structure looks like this. ClO2 structure looks like this. You have chlorine here, then there is double bond O, and then finally there is oxygen, and these are the lone pairs, and finally you have the negative charge. Now again you can see very well that there is involvement of d pi p pi bond, right? So you can see very well that ClO2 is having the d orbital in p or bonding. So yes, it will be counted as the sixth one. And NO2. Let's see what about NO2. So NO2 has, we will write here that NO2, if we talk about NO2, it has no d orbital. So if it does not have any d orbital, definitely the involvement in p bonding will not be there. So NO2 also does not have d orbital, so definitely it is not going to have any involvement in p bonding. So finally you have how many? 1, 2, 3, 4, 5, 6. So these are the 6 compounds which will show. So how many of the following compounds have significant involvement? You will say that 6 compounds. 6 compounds have involvement in what? Involvement in d orbital in p bonding. Involvement of d orbital in involvement of right d orbital in p bonding. D orbital in p bonding, right? This is very important. 6 compounds. So the answer to the given question is 6. I hope you have understood. Thank you very much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.